Hi there. This video is captured for is recorded for Omar. So hi there. This is Amir. So you sent me two papers. I chose one of them, which is this one called Tumoral PDL1 does not impact time to treatment discontinuation in EGFR and blah blah blah. So first, I am seeing two or three Kaplan-Meiers. So you should know that which one is your endpoint for systematic review. I assume that you want to perform meta-analysis on overall survival, but you can do the same steps for other endpoints. First, I print a screen and capture this one and save it in my computer, and then I load it here and define x-axis from 0 to 100 and 1000 and 1600. So why I choose 1600 and not like here, it's because I should define the endpoint for x2. So I chose 1600 since like I can know the exact point, and I will miss this part, and I guess it is not that much important. So you can also try 1800, so no difference. And also y1 to y2, and I also told this web digitizer web plot digitizer and that my x1 and x2 is 0 to 1600 and my y1 and y2 is from 0 to 100%. So I will try OK, and you told me that you want negative and high, so I should add a point. So I added a data set. Like you can click here in the data set and add a data set, and then you can rename them by double clicking on them. You can also adjust the color of each one using this display color button. So after that, we should capture these data points. There are two approaches for doing this. If you have number at risk, you need to let me show you. If you have number at risk, you need to just like capture points on these timelines. For example, in this scenario, I should select data points for 200, 400, 600, and so on. So, for example, if I want to get the data using these numbers, I just need to I usually put a paper on my screen and then I select these points. For example, 0, 200, 400, and so on. But if you don't have these points, I will show you how you should get all possible data points in this line. Let me clear this thing. Yeah, I will just delete these 3 points. So for selecting all the like maximum number of data points in this line, in the cases that you don't have the number at risk, in the cases that the published paper didn't report the actual at-risk numbers like this one. So you can use like this pen and you can get all of you need to just highlight the line, and the next thing you want to do is to select the color of this line. So you will need color picker. picker. No, not this one. Oof. Since the quality of this figure is not that much good, I guess I should download it so the quality would be improved. So let's start things from the scratch. What happened to this? There are so many problems when you want to do something, so that's not unusual. So every time that you want to do something, there are so many unforeseen issues, and you should just cope with them and find a solution for them. So I hope this version of the figure to have better quality. Yeah, okay. Now dataset high, and this one is negative with the color of blue, and this one has the color of green. So let's do this for negative one again, hoping for better results. Let's first pick the color. Ah, I really can't get this color, so I will add some blue to it by hand, hoping for better results. No, what about 100? A little bit better. Yeah, I guess this one maybe work for me. No, it's not working. If you can also select all of these things by hand, but we don't want that. We will try other options and then we will go for doing things with hand. Ah, better now. Okay, you should just delete some points. Yeah. I guess this one is a little bit better. So, ah, let's add some point here and also here. The problem is there is no better tool than this one. So do anything you want with this one. There is no better option for you. Let's get this one. Yeah, better. Let's decrease the width and hope for a better result. I am not good at talking and doing things at the same time, since there is only one brain cell inside my head. Yeah, I get it. I guess this one would be better. Yeah, you can see that. You can see that it's a lot better now. We just need to delete these points and also this one. Yeah, that's it. Yeah, we can consider it done. So the next thing is to get these numbers, and since like the number of points in the green line and the blue line right now is not equal, we need to adjust this using our own formula in the Excel. I will show you that one. So I don't want, as you said, I will not pause the video so you can see everything that I do. I usually do these things like every time I'm dealing with these formulas and these conversions, so it will take a little bit more time. View data. So I should now divide these two columns. The first one was the blue one. Let me color it to remember the outcome, and the next one is high, right? Yeah. So let's work with this one. uh, so in the column name, let me get up. In the data, you can try this tool called text to column, and you should check this button and then define comma as the separator, so it will get it will give you two columns. Also the same process for the second column, and you get another column. So the first one is the month, the blue one is you should be precise for the naming of the columns and naming of the things, so you can make sure no problems or no mistakes uh, would happen. The blue is negative, neg, month, neg, risk, high, month, high, risk. So we should get these points to the equal number at the equal months. Uh, as you can see, they are roughly the same. So you can do this by hand, or you can do this using some formulas. Let me remember my previous formula, and I will pause the video and then explain the formula to you. So I transferred I want the data set to be like this, to be the months like 0, 100, 200, and so on, and also have the negative and high risk at the same time. Why I choose 100? Because I have only like 30, as you can see here. There are only 33 yeah, there are 33 rows here, so the maximum would be 33. You can also add some rows to these sheets, but usually in some cases they will be cropped if you do this. So let's go on and do this by hand, okay? The best option is to uh, give your logic. Uh, use your logic and also use some simple math. So 0 is like this one. This one is the 0, and we know that the risk of something happening at the 0 time is like 100. Not the risk, but like it's the Kaplan-Meier, so it's not exactly the risk. I'm using the word risk just to be uh, more easy going on this. So we have I'm using these things. So for 200 this one, and for 200 is like not 82, not 79. I will give it 80. And what about 300? Yeah, this one for 300. This one for 300. You can also find the value, exact value for 300 by finding the points and dividing it by, like, there is a line. You can fit a linear regression to this and find the exact value for 300. I will skip this. It takes a lot of time, and I just want to show you how you can do this. Okay, let's, like, for this one you can just average it, since 400 is roughly between these two data points. I will average these two, and average of these two is roughly 73. What about 400 here? Yeah, same goes for this one. So as you can see, the points are so close to each other here. So I will just put 50. So this one for 500 and this one for 500. This one for 600 and this one for 600. This one for 700 and yeah, this one for 700. Let's delete these points. Just a moment. نیلوفر ناهار میخوری؟ آره الان میایم. Sorry. I should go for the lunch, so I want to continue living, so my wife calls me. So let's move on fast on this, and then I can go for the lunch. As you can see, there are no big difference on these things, and it is not possible to go upward. This is an, as you can see here, everything goes downward and the risk is decreasing. So this would be cause a problem, and I will solve it just by hand. Yeah. So 1200. This one, I guess. Oh, still it is 100 and 1300. Yeah. What about 1400? Why we don't have it? Okay, the green line would be come to the 0 at this point. So I would come up with 0, 0. Oh, sorry, 0 and 0. And what about the blue line? Yeah, I will go with this one. What about 900? This one for 900. 43 points. This one. This one. Maybe this one and this one. This is not the best option for you. Okay, if you have time, you can just find the exact value for these points by using an Excel formula. I couldn't find the previous formula and I am short in time, but you can, like, just find the exact times by using, like, formula. Like you can find the difference between these two per each month of follow-up, and then you can divide the you can find the exact, like, if you want 112 1400, you can find that these 14 months would cost us how much. So let's calculate this for this, just one example. So I know that for this one minus this one, for this amount of month, I have this amount of decrease. So what would be the difference for each month? You can just divide this by your month. So this is number of months. If you want to find the exact value for 1400, you just need to first find the number of months that, like, between 1400 and this number, and just multiply it by the difference per month. So And also this is the difference. This is the difference, and I should just add this add this difference to our previous data point. So this is the exact value for 400, 1400. So yeah, it is a bit different, as you can see. Oh, okay. You should, when you want to copy something, it will copy the formula. You should paste the value only. I will upload this one on YouTube also. It may help someone out there. So where is like 1500 is like this, and for the final output it's something like, let's like check it with, yeah, that's it. So these are my number risks, and I should add this to the my sheet, and also I should complete these parts. So I will call the research group as like there is no difference. You can just name them as you want. I will call it negative and high PDL1. Just remember that for each extraction, you should just do the same. If your research group is negative one, you should do the same thing for all of the extraction. And also you should check this with other hazard ratios from other papers. So yeah, I will extract this data. Just I want to show you briefly. So the minimum follow-up is 0 and the maximum follow-up is 160 months. So I can remember that I just need to add these things. So what was effective number alive at the start? So you should know each data group, each group have how many number of participants. I will just check it. I don't want to use this number to give a better example. So I will go to the paper, and I guess I should find a table that's saying how many individuals have high and how many individuals have low. I usually like, okay, result here. You can see that here. 57 patient as negative, so 57 is our number for negative, and also low, and 22 as high. Okay, so these are our numbers. It is defined here. Effective number alive at the start. So this is our timeline, a start of interval, and these are all times. So let's paste these times. It already have 0 on 0, so yeah. So I should just paste the risks for the negative. So what is the problem? Okay. So I guess I should delete this one. What's the matter? Like I said, there are so many unforeseen things that you need to deal with when you are doing projects. So what is the problem? So the problem is, let's close this one. Also get some more space. So 70. So all of these things should go downward. Like no value should be higher than the one before it. I will just check this one. Let's just delete this one and see what happens. So what's the problem? It usually gives you. Oh, okay. Maybe it needs this. Yeah, I sorry, my bad. I should also give it these things, and also let's move it to, so let's say the maximum number is 100. Yeah, everything is fine right now. So we gave it these extracted data points and also these extracted data points for each uh, exact interval. And I also told you how to calculate it exactly, but in this example, I just go through the handy handy method, which is not accurate. So yeah, let's move on. So after that, we should complete these sheets. And if you want to know why you are not seeing the hazard ratio here, you just need to check this data sheet. So as you can see here, I want the method data from the curve. So yeah, what data do I need? Data entered. Like there's, so there is a problem here and we need to fix it. Oh, the problem is here. So what's the problem? Okay, as you can see here, 50.58 is higher than 50 and it causes this problem. I should just like increase this one or decrease that one. So it would be, this problem would be solved. So yeah, this is finished. As long as you can also see the curve here. So this is the curve that this is the data that we gave it. You can just roughly compare it with this one. Let's see how much similar are they. Yeah, not bad. Yeah, not bad. We can also see these points. But as you can see, it is not the exact Kaplan-Meier since we are just sampling the points from the real line. So why it's not showing the, oh, maybe I am not completing this one. So you should also put these things to it. For studies that didn't reported the number of excluded, you can just put number of patients analyzed equal as number of patients that that were entered in the study. But let's just look at the paper. So here it is. So this is the number of cases. Actually, you can use these things, but I don't want to do so. So I would just want to find it within the text of the high. Here. Median time was this month. I guess we have median time somewhere. Actually, this study already mentioned the hazard ratio itself, and it is just an example. If you want the hazard ratio, it already gave you the hazard ratio. So there is no need for doing such hard work in this study, but this is just an example. So I would just use these data that they provided. So 57 for the PDL1 negative, 57, and 22 as high. Also the same for the analysis. but as you can see, the numbers are different. As you can see here, for overall survival, it is the same, but for time until treatment, there are some excluded cases. So that's why I said please don't extract data from just curves. But anyway, so observed event means how many patients actually died. So we need to see dead or survived. I usually read the whole paper, but for this example, I don't have the like interest to read the full paper. They should usually report their number of survival in the tables, and if you can't find it, you usually can't do the calculation. Anyway, we can find the number of death maybe from some other parts. Yeah, I can find the number of deceased cases. So let's see if it works. No, it's not working. But if you had the exact numbers, like let's just copy and paste it here. That's exactly why I don't like to extract data from just curves. They are inaccurate and it is much harder. So there are so many cases that you usually can't actually calculate the hazard ratio because the sufficient data is not presented at the paper. So I just need to extract data from here. So it is 52, 42. We can do this like this also. I just want to show you uh, how much easier is finding the hazard ratio using the actual at-risk data. So this is 55, 52, 42, 31, 22, 17, 7, 3, 1. And for this one is this is high. So 22, 17, 11, 9, 5, 9, 5, 1, 1, 0, 0. Yeah. And then you can just add it here. So this is the number alive and survival probability, and this is the amount. Okay. What's the problem with this column? So okay. So as you can see, there is a problem with 0, but it calculated the hazard ratio. As you can see, the extraction of hazard ratio from Kaplan-Meier should be done just for the survival curves that presented numbers at risk. Look how much easier it is to calculate it using this sheet compared to this one. I couldn't find the number of events, so maybe that's the problem with this problem in finding the exact points from the method of extracting data just from the curve. So let's look at this one. I usually get good idea about the method. So as you can see, data from the curve is done here. I don't know why the 10. So the method 10 is this sheet, is the sheet that only use the numbers from the curve. I don't know what is the problem with it. So we can also enter the time that you are doing this so everybody can know about that. And these are the curves that we are. As you can see, there are not a big difference between them. But my problem is why this one is not working. Let me check it with the full paper and read and get back to. So I found a silly problem. So if the actual proportion of patients on treatment becomes 0, the whole model will fail. So the only thing that we, that's the funny thing about doing things. There are some small mistakes or small issues on the back end that causes this problem. So if I give it at the 0, if I give these 3 points, data points as the 0, it will fail to generate hazard ratio. But if I gave them just 1 or maybe just what, let's look at like, is it, yeah, it also works this thing. Usually in statistics, in some cases, it is common to change the 0 to a little bit more to avoid these kind of mistakes. So the only thing that we wanted from the data is that these points, but the problem that I faced and I found that the number 0 is not, it will cause some problems. So that's it. And also, I guess you don't need any of this data, like none of them. You just need data points. And I also tested that by using more data points, the HR would be more accurate. So the interesting part of this video would be this one. So the hazard ratio using this only this method, including the data points from the curve, is 0.53. The hazard ratio using the data points and also numbers at risk would be 0.6. And let's see on the actual hazard ratio. So this is the important and interesting part for me because I don't also. So yeah, here is it. So it's like 1.7 is the hazard ratio when negative is the reference value. So let's see what is our reference group. Our reference group is like, let's change this. I just want to see what happen if let's change. Our direction of effect is different, so I can also transform this hazard ratio in opposite direction, but I just want to show you how accurate these methods can be or can't be. So like I'm just what I'm doing right now is just I'm just changing the reference group, so I can compare them with my HR of 1. Can you see that? That's how inaccurate this method is. Interesting. So let's also change this one. Yeah, 1.6. That's amazing. So as you can see, this method is not accurate. It will generate false results and that's why you shouldn't try this method. The points from the Kaplan-Meier curve is not enough, and you will need the actual numbers at risk. So also there is a problem here that I don't know what is that. So yeah. Oh, okay. Okay, I should let me. Yeah, 1.6 is our hazard ratio extracted from Kaplan-Meier, while we have the numbers at risk, which is roughly the same as the univariate hazard ratio. And as you can see, extracting data just from the curve is not accurate. And that's the point of this video. So I'm sorry that this video is messy, and I'm just doing the real thing, and I want you to go for every step with me, and I hope you like it and it can help you. And thanks to Omar for emailing me to give him hand on this. Bye bye.